Hey, this is Warren Redlick. Autoline did an interview recently with the chief scientist of Toyota. Shed a lot of light on Toyota's EV strategy or non-strategy. This is going to relate very much to Tesla, and the competition is coming. Are you ready? Let's go.
My special guest today is Gil Pratt. He is the chief scientist at Toyota and also the CEO of the Toyota Research Institute. Gil, so great to see you again.
So this is Gil Pratt. He is the chief scientist at Toyota. John McElroy over here is the Autoline guy, and he interviewed Pratt. This was a fairly lengthy interview. I cut snippets here and there. We're going to go through this and cover what Pratt has to say about Toyota's EV strategy, about solid-state batteries, about what Toyota's strategy is going to be for EVs going 2026, 2030, and so on. So let's dive a little deeper.
For us, it's really a question of looking at what's likely to happen in the future and also thinking about what we don't know about the future and coming up with a strategy that can be adaptive to all the different possibilities for the future. What has changed, to be very clear about it, is we're much more open now about what those possibilities are.
To me, that was a lot of mumbo jumbo. I have BS in my description of that clip. Not a lot of substance there, a lot of buzzwords and junk. I just didn't see a lot there. You know, we're starting to see where we're going. That's the start. We're going to get it in a lot more detail coming up.
And that's a rather remarkable number, which is by 2030, we're expecting that 35% of our vehicles will be battery electric vehicles or BEVs.
By 2030, which is 8 years from now, they're expecting that 35% of their vehicles will be battery electric vehicles. Net clear, it was never clear in this video whether he's talking about hybrids, whether he's including hybrids in the BEV category. Normally, you don't include hybrids in the BEV category. But think about this. 8 years from now, Toyota expects 65% of its models to still have internal combustion engines. They claim they're going to have 35% of their models are going to be BEVs. Is that 35% of vehicles produced, or is it 35% of the models that they're selling? Not clear. Later in the video, you're going to see he still seems to think, and Toyota still seems to be focused on hybrids moving forward rather than full battery electric vehicles. Very little substance in this video about actually having full battery electric vehicles with no internal combustion engine. But next, we're going to talk about solid state batteries, which is something that Toyota's been relying on. Pretty interesting stuff here about solid state. There's a lot here.
That solid state battery is going to be tested first in a hybrid electric vehicle, which sounds like kind of a strange thing to do because, after all, the great promise of solid state batteries, one of the great things is that they might be able to be charged much faster than conventional lithium ion batteries. But we actually think that because the costs of the battery cells are still quite high, no one has yet really figured out how to manufacture them in high volume with low cost.
Number one, you saw right there that when they start with solid state batteries, it's going to be in a hybrid rather than a full BEV. And he has some pretty good reasons for that we're going to hear soon. But he also says that the world hasn't figured out how to manufacture lithium ion batteries at scale at low cost. And this really isn't true. Tesla is using batteries, making vehicles that are cost competitive with Toyota's vehicles on a total cost of ownership basis. They've been making vehicles like that with batteries at higher prices, and that Tesla is rolling out what will be a lower cost way of manufacturing nickel-based batteries. CATL is ramping production of lithium iron phosphate batteries. Tesla is finding a way to use lithium iron phosphate batteries more efficiently. Those are getting produced at large scale. There's a lot of things that are happening. There's also a potential introduction of manganese in lithium iron phosphate batteries, or maybe a straight manganese battery. There's a lot of innovation, particularly by Tesla and companies associated with Tesla, CATL, LG Chem, Panasonic, Tesla itself, maybe one other. There's a lot of innovation there, and there's a lot of progress, and particularly with lithium iron phosphate batteries, we don't see the supply chain issues. There's plenty of iron, there's plenty of phosphate, there's enough lithium to supply lithium iron phosphate batteries. There's plenty of that around. So Toyota's view that it's too early and there's not enough batteries out there. I mean, there's not enough batteries for everybody out there. The idea that they're not being produced at scale at low enough cost seems iffy. Let's hear a little bit more from Gil.
That a hybrid vehicle is actually the right place to start. And the reason is the battery pack in a hybrid vehicle is much smaller than in a battery electric vehicle. The power levels of charging and discharging, because that battery pack is smaller, when you press on the brakes and you have regenerative braking, or you hit the accelerator, the actual power per cell is somewhat higher than it is in a BEV, and the number of cycles that it's going to go through are quite a bit more. So actually, it's a tougher job to put a battery inside of a hybrid electric vehicle than a BEV. So we are starting there so that we can learn the most doing it.
The point there is that when they develop their solid state battery, and I should say if they succeed in developing their solid state battery, because there's going to be some questions about that as we go through, their first use will be in a hybrid, because the hybrid use is actually more demanding on the battery than full BEV use. And this does make sense. When you do regen, the full energy of the regenerative braking is going to the batteries. If you have fewer cells, they have to absorb more power. If you have a large pack and you're absorbing the regen, there's more cells to absorb that power. A smaller number of cells have to absorb the regen power. I think another point would be, if you have a shortage of batteries, then if you make smaller packs for hybrids, then you can make more vehicles. So there is some logic there, but he appears to be in denial about what Tesla is doing with massively ramping production of battery electric vehicles, full battery electric vehicles, and with Tesla suppliers massively ramping production of lithium iron phosphate cells and nickel-based cells. So there's more about hybrids next.
That's absolutely true that a hybrid battery is going to be under much more stress. Why go that route?
Well, we need to learn, and we think that the important thing to do is to do what we call Kaizen. That's continuous improvement, where everything that we do, we never make a perfect car. What we say is that we make ever better cars.
It's an important point here that Pratt is correct. This is a very common thing with Japanese companies, and Toyota in particular. Incremental improvement, get a little better, get a little better, get a little better. This works really well in an environment where nobody is doing radical innovation. The problem is that the EV space is seeing radical innovation, particularly from Tesla, but also from others. You're seeing radical innovation, you're seeing major changes, and incremental innovation on a stale, dead model, internal combustion engines, is not going to get you where you need to be when someone else is engaging in rapid, massive, radical innovation. Tesla's making big changes constantly, and they're moving forward really, really fast. And Toyota's slow, tortoise-like approach isn't going to work in this situation because Tesla's radical innovation is succeeding. Tesla's not the hare. They're not running out of space to run. They're not going to get tired. They're continuing to innovate dramatically, and Toyota's going to get left behind. There's a little bit more to this clip.
In this same way, we're sure that the battery is going to be good enough for this use, but we're also going to learn a whole lot by doing it. And we expect that that's a good kind of stepping stone for price reduction in the future, where it will then become practical from a cost point of view for a battery electric vehicle.
It sounds like what he's saying is the solid state batteries, and he says this again later, when they start producing the solid state batteries, they're actually going to be fairly expensive. And this is just generally true. When you succeed and come up with an innovation, you have to scale and manufacture it at large volume, and it takes time to manufacture it at large volume. When you're manufacturing it at low volume, it ends up being very high cost. And until you can scale that to produce in high volumes, it's going to be a high cost solution. It's not going to work to use batteries that are very high cost to manufacture to put in full battery electric vehicles to compete with Tesla, which are using batteries that are much less expensive to deploy. Even if solid state is somehow better in certain ways, if the cost is too high, it's not going to work. They have to make sure it works first in the hybrids, then manufacture at scale, get the cost down, and then they can look at full battery electric vehicles. Next, Pratt gives us a timeline for the solid state batteries.
I am not sure. I know it will be in a vehicle that's actually on the road, but I'm not sure exactly what the scale of it's going to be. We still have a few years to go. It's 2022 right now. We have 3 more years. We will see how the development goes, and depending on that will depend on what scale it's going to be. But we're sure that it will be ready for some kind of testing within 3 years.
Their plan for solid state batteries is not, we're going to be selling cars with solid state batteries in a few years. Their plan is, we're going to be testing it in vehicles in a few years. So maybe the first early models of solid state batteries for Toyota in hybrids are 2026 or 2027. By that time, Tesla's making more than 10 million vehicles a year and is the largest automaker in the world. Toyota is playing a losing strategy it is plainly obvious that this is a losing strategy, that they can't win this way, and they've got their heads in the sand. They just don't see it. The train is coming. They're about to get hit, and they just don't see it. Next, Pratt's going to talk a little bit more about what they have to do first to get where they need to get before they get to how they're going to reduce cost, which is going to be the clip after this.
So we are thinking about a wide range of different hybrid vehicles. In fact, there's going to be many different ones to choose from. I don't actually know which one we're going to end up choosing as being the right target to start with, but we specifically, we want to start with the most difficult case in terms of the electrical characteristics, how we're going to subject this battery to the harshest conditions, and then if it can do well there, then it's just a matter of getting the cost down and make it usable in a wide range of other vehicles.
So first of all, you can see he's talking about a wide range of hybrids. So when he says 35% of vehicles will be battery electric vehicles in 2030, it sounds like he's really talking about hybrids rather than full battery electric vehicles. That's what I'm hearing. Second, the plan for solid state is when they start to run it in a vehicle, they're going to pick one vehicle. So 2026 or 2027, they're going to start deploying solid state batteries in maybe one hybrid to see how it runs. And eventually by 2030, it'll spread out to a wider range of hybrid vehicles. This does not sound like an optimistic timeline for Toyota to compete with Tesla. And, with all the people saying the competition is coming, when Toyota decides to turn its guns on Tesla in the EV market, watch out Tesla. When is Toyota coming? They're a long way off. So next, let's hear Pratt talk about the cost of manufacturing.
How low can the cost go on that? I'm told right now that lithium-ion battery costs are just under $100 per kilowatt hour. Where do you think you could come in with your solid-state battery?
Just to be clear, if you have a 50 kilowatt hour pack and it's $100 a kilowatt hour, then the battery cells are $5,000 in that car. If you have a 100 kilowatt hour pack, it's $10,000. So in a Model S or a Model X, you're talking about $10,000 for the cells if it's costing $100 a kilowatt hour. In a Model 3 long range, you're talking about $7,500. Model 3 or Model Y long range, you're talking about $7,500 to $8,000. In a standard range Model 3, you might be talking about $6,000. But if you're talking about a lithium iron phosphate battery pack in a standard range Model 3 or Model Y, that probably lowers the cost a bit further, just to give you some context there. But in a hybrid, you might be talking about a 10 kilowatt hour pack or a 5 kilowatt hour pack, and now the cost gets really low. That's like $500 for the pack, or for the cells in the pack, or $1,000 for the cells in the pack. So the cost of the batteries in a hybrid are not that high.
Well, so our solid state batteries now are higher in cost, and so that's of course part of the problem. When you're manufacturing a lithium-ion battery, you essentially are applying a paste to each of the foils that are used within there. There's a dielectric of some sort, there's a barrier of some sort that goes in there, and then it's all wound up and put in some kind of a can, or if it's what we call a prismatic cell, it's folded back and forth and put in something that's more rectangular in shape.
He's talking about the cylindrical cells that Tesla uses in most of its vehicles, and Lucid and Rivian are using the 2170s or the 1865s or the 4680s. You have a cylinder, and you roll up layers inside the cylinder, or in a prismatic, it's a rectangular box and you layer them. There are also pouch cells that are used in some contexts. He didn't mention those, but let's keep going.
The manufacturing ways for making a solid state battery are significantly more complex. And they're actually closer to the way that semiconductors are made than the way that batteries traditionally have been made.
Saying that manufacturing solid-state batteries is more complex does not sound like a recipe for making them at lower cost. On the other hand, if they are able to ultimately manufacture them like semiconductors, then maybe you're printing them with large-scale machines, and when you do that at very high volume, that could get the cost down. There's two sort of sides to that. It really wasn't clear what he meant, but complex manufacturing is usually more expensive than simple manufacturing. So I don't know how you get the cost down with complex manufacturing, but maybe he can explain that at some point. I don't think it's in here.
So making one for the lab bench isn't that hard, but making them in volume, in production at very low cost is quite hard. And so we don't think that within the next few years, we're going to have cost parity with non-solid state cells. But we believe that if we can get the lifetime issue solved, if we can get the power density and energy density issue solved, both in terms of volumetric density, and also density by mass. If we can get all of those things solved, the cost is sort of the next stage for trying to make this thing all work. So it is going to be at least some time till those costs come down, but we are very excited about it, and significant progress is being made.
Number one, did you hear all the ifs? They don't know if they can get the batteries to work the way they're going to need to work to be used in cars at all. And they'll know the answer to that in a few years, which is 2025, 2026, maybe 2027. They're going to have a better idea whether this will even work. And once they get there, let's say 2026, that's when they start figuring out how to manufacture at scale, which is going to take a couple of years at least. So now you're talking about 2028 before Toyota has any significant volume of solid state batteries to put in vehicles. And where is Tesla in 2028? Tesla's way past 10 million vehicles a year in 2028. They may be at 20 million vehicles a year. I think they're going to have a robo-taxi fleets driving around the world, reducing the overall demand for vehicles. I don't see how Toyota survives. I don't see how any of the internal combustion engine manufacturers survive. This is just a train wreck. We're just watching a train wreck happening. And this guy, Gil Pratt, very clearly doesn't get it. That's what I'm seeing. Interesting topic next about the fast charging potential of solid state batteries.
Charger these days, sort of the bleeding edge is 20 to 30 minutes to get an 80% charge. How might a solid state battery stack up against that?
So we aren't sure of where the limit is yet. So the big idea is that in a solid state battery, because the electrolyte is much, much thinner, and it's also a solid material, the resistance to current that goes on there is much less. And so the power levels that you can use both for charging and discharging without generating excess heat can theoretically be much, much more. And so that's actually what we're pressing on the most now. The second issue that looks very exciting is a potential for a lifetime that's much longer than traditional cells. And this particularly has to do with a lifetime under fast charging. Many people focus on the number of kilowatts that comes out of the DC fast charger as an example, and saying, well, I have a 150,000 watt DC fast charger, so of course I can fill my car up in just a few minutes. But they forget that what happens, of course, is that the batteries in the car get hot, and it doesn't stay at 150 kilowatts for the whole charge. It actually begins to taper down.
A couple of things here. Number one, he mentioned 150 kilowatts. Tesla's chargers now are 250 kilowatts. There are some 300 or 350 kilowatt chargers out there. So that's kind of strikingly behind the times on what's actually out there. And then he's correct that there's a taper. There's an early comment that the Autoline guy said earlier that, 80% charge in 20 to 30 minutes. That's roughly true. I can say on my Model 3, I don't think I quite achieved 80%, going from, say, 10% to 90%. 30 minutes is probably close. It's in that ballpark. Some of the newer vehicles might charge a little faster, but there's fundamentally this problem that as the battery gets more and more charge in it, you can't charge it as fast anymore, and Pratt's going to go into that here.
One is because of heat, and the other one is that as these lithium ions are moving from one side of the battery cell to the other, if they move too quickly, they don't form an even coat on the other side. They don't go in between the atoms that are set up on the other side in the right way, and it can degrade the lifetime of the cell.
Really good channel to watch for understanding this battery chemistry stuff that he's talking about. He's mostly making sense to me. Watch the Limiting Factors channel. He has a lot of videos where he talks about how battery chemistry works, and it's a little bit less about heat and a lot more about what he's saying here, that once the battery starts to get fully charged, it gets harder to get the charging. You're transferring ions from one side of the cell to the other, from the anode to the cathode, and getting the ions in there in the right way can be problematic. And if you do it wrong, you can actually damage the chemical structure of the cell, making it harder to store more energy. So pretty interesting stuff. I'm going to let him keep going here.
And so what we're hoping in the solid state space is that, in fact, we're going to solve both the power density issue and also the lifetime issue. But the way that we do things at Toyota is very much step by step, and we try very much to be humble and not to claim that we're going to do anything sooner than we're sure that we are going to do it. Mm-hmm. So what I can say is that we're on track to have something in a hybrid test vehicle within the next few years. And exactly what the scale of that's going to be, I am not sure of, but it's going to be out there, and that will be sort of the next step in trying to make these things real.
Again, you hear the hesitancy. In a sense, maybe he's sandbagging about what Toyota's prospects are in the future, but it just sounds like, they really aren't there yet with their solid state battery chemistry. It's going to take a while before they get there. Who knows? Are they really going to deliver this in 3 years? Are they going to surprise us and deliver it 1 year? Seems unlikely. This is there's a lot of hurdles here. It's definitely true. There's a lot of people who, as we understand how solid state battery chemistry might work, if somebody can get it to work, it really should be able to last longer. It really should be able to charge faster, and it really should be able to store more energy for a given weight or a given volume. And those would all be great things for vehicles. The problem is if it takes this long to get there, and all the while Tesla and its suppliers are getting their costs down and they're making more and more efficient vehicles, get to the point where, like, is any of that really necessary? Once you have 300 miles of range, just my opinion, once you have 300 or 350 miles of range starts to become irrelevant. Fast charging isn't as important as you might think, because most of the time you're charging in your garage when you're not in a hurry. The times when you're in a hurry, when you're charging, just in my own personal experience, if you drive 500 miles a day, then you're going to have a lot of fast charging, and that time's going to matter. But if you go on 2 trips a month, which is basically my story, I go on two maybe long trips a month, and I have to supercharge a few times each of those days, maybe twice each of those days. It just doesn't add up to that much time. And when you're supercharging, you go to the bathroom, you go get a drink at a convenience store, it really isn't that much of a burden. So getting the supercharging time down to 10 minutes or 5 minutes is just not going to make that much of a difference in most people's lives. From my experience with EVs, I'm sure there are people who are exceptions to this, but I would say in general, for people who own Teslas now, the fast charging is not nearly as important as people think. Are there moments when you wish it would charge faster? Yes. How often is that as a part of your experience with the vehicle? Not very much. Next, a little bit about the safety of solid-state batteries, lithium-ion batteries, etc.
Are solid-state batteries better at preventing fires from happening?
So the answer to that is that they have the potential for being safer. And the reason is that sometimes the electrolytes that are used in traditional lithium-ion cells are either flammable as a chemical by themselves or have the potential of breaking down into components that are flammable themselves. And so solid-state batteries, if they're designed with particular chemicals, can be less flammable inherently than some of the non-solid-state cells. In addition, there's always this engineering trade-off that goes on. So if you, for instance, have a battery and you push it really hard, if you charge it really, really fast, if you draw a whole lot of power from it, if you let the temperature get too high, what often will get traded off is both lifetime and sometimes, if you push it really hard, the safety as well.
So there's a couple of things I just want to talk about here. Number one, I don't know why the Autoline guy asked this, John McElroy. I don't know why he asked this. Lithium-ion batteries, Tesla's batteries, whether they're nickel-based or iron phosphate batteries, do not have a significant risk of fire internal. And I think McElroy mentioned this, maybe it's not in the clip, but McElroy mentioned this, that internal combustion engine vehicles catch fire a lot. Current battery electric vehicles, particularly from Tesla, just don't catch fire very often. It's actually pretty rare. And they're getting better at that. So the fact that solid state batteries might lower the risk of fire, if you're once you're down that close to zero, the difference is pretty small. So it's not clear that this is that big of a deal. And he's making a lot of sense about the prospects for this being safer, but we'll see. Let's listen a little bit more to what Pratt has to say.
And so when we're designing a battery system, when we're deciding how to use batteries in any of our cars, we're always looking at all of these parameters. And of course, for us, safety is the most important one. So we want to make sure that is really never a serious issue. And if necessary, we'll trade off the other things, including the total capacity, how many kilowatt hours we are going to store.
The Limiting Factor channel, again, has talked about these trade-offs, that there's different things you're trying to achieve. You're trying to achieve long battery life. You're trying to achieve a lot of storage. You're trying to achieve fast charging. And then you're trying not to let it get too hot, and you're trying to make sure it's safe. There's a lot of different things that go into batteries. And if you push one area, you might create other problems in other areas. So it is a balancing act. It's a balancing act for everybody. He's not wrong about that. Next, Pratt's going to talk about the battery life of these vehicles, how long they will last, and how much charge will they have over 10 years.
One of the things I hear from people all the time who are concerned about electric cars, worried about them, is, oh, I don't want to spend all this money and then the battery's going to go bad and I'll have to spend a fortune to replace it. How long can you make these things last?
So this is extremely important, John. And I think that when people, take the money that they've worked so hard to earn, and they, put it into purchasing a car, that is a tremendously important asset that they have bought. And they want to make sure that the value of their car doesn't go down with time. What we've decided is that our batteries will retain at least 90% of their capacity for 10 years. And we think that that is a very sort of reassuring figure for most folks when they think about buying one of these cars.
This is a little tricky. Saying 90% over 10 years, what tends to drive battery capacity over time, and this may be different with solid state, but what tends to drive battery capacity over time is the number of cycles they've gone through, the number of times you've fully charged it and fully discharged, or charge cycles in general. The charging and discharging cycles. Discharge is when you're driving it and it's draining the battery, and charging is when you plug it in and it's charging the battery, or filling up the battery, so to speak. Not really filling anything up, by the way. I guess it's putting electrons in there. 90% in 10 years. Well, maybe that's for a vehicle that's driven 12,000 miles a year. It might be different for a vehicle that's driven 25,000 miles a year. It's probably more accurate to talk about the amount of battery life left after a certain number of miles. So 100,000 miles or 200,000 miles. If he's thinking 10 years at 10,000 miles a year, that's 90% at 100,000 miles. That's not terrible, but it's not that great. And Tesla's already basically doing that in most of their vehicles. And the other thing is, if you can get the range to be long enough, but let's say you started having 500-mile range as your normal range, and then you lost 20% over 200,000 miles, you'd still have 400 miles of range, which is still very useful. As someone with a 300-mile range vehicle, 400 miles of range would still be great. So I think once they get the cost of batteries down, and if they can get the gravimetric energy density, the mass, if they make the batteries more efficient in a variety of ways, how they use them, how they package them, and the batteries themselves, that solves a lot of these problems a lot more than worrying about this little detail. And I don't know that the range or the capacity matters as much with a hybrid as it matters with a full battery electric vehicle, because the hybrid can always fall back on its gasoline. That's what it's basically going to do. Next, of course, more about batteries.
Well, if we can get to $100 per kilowatt hour, we'll match the price of an internal combustion engine. Now I'm told it really should be around $80. What are your thoughts as to where the price should be?
So it's not a hard number. It's sort of a trade-off. And what you find is that as you're approaching these numbers of $100 per kilowatt hours, 80, etc., then the bracket of when cars are actually practical and competitive with gasoline-fueled cars, they begin to overlap each other.
This is nonsense. Teslas have been competitive since the very beginning, when batteries cost a lot more than $100 a kilowatt hour. And for the last few years, I think Tesla's still in the ballpark of $100 per kilowatt hour. Teslas are extremely competitive. It's maybe less so with other battery electric vehicles from other manufacturers, but Tesla's electric vehicles are extremely competitive at whatever the current price point is. And I think with the lithium iron phosphate battery cells, it's dramatically less than $100 a kilowatt hour, and will probably trend down to maybe $40 a kilowatt hour. So one of the things Pratt didn't get into is what is their long-term hope for dollars per kilowatt hour on their solid state cells. If they're only hoping to get to $90 a kilowatt hour, and Tesla's expecting to get to $60 a kilowatt hour on their 4680 high nickel cells, then even if the solid state batteries are better in some ways, they're still much higher cost, and it's going to be even harder to compete. And the batteries that Tesla's already using are good enough, and the newer batteries are going to be even better. It's like they're chasing and they're too far behind, and their incremental approach is not going to catch up to somebody who's innovating. This goes back to that radical innovation. If you're in a space where somebody's innovating radically and you're innovating incrementally, you're going to get left behind. Next, McElroy asked what I thought was a really interesting question about how you design the chassis for a battery electric vehicle. Tesla designs its battery electric vehicles from scratch as electric vehicles. Toyota has been reusing in some ways a platform that's used for internal combustion engine as well as batteries. So let's hear what Pratt has to say about that.
A lot of automakers, including Toyota, have modified their ICE architectures, the platforms of their piston engine cars and trucks, to be able to accommodate batteries and electric motors. Others are going completely clean sheet design. From not carrying over anything, just from day one, it's going to be designed as a pure electric. Where does Toyota fall on that?
So we are somewhere in the middle. And I think part of this is because we do have, many decades of experience with making cars. And a lot of that know-how is inside the particular design of the chassis and the other parts of the architecture of the car. We don't want to throw that all out and just start from scratch, because we worry that if we do throw that out, some of the very hard-earned lessons will get lost in the process. So as you may know, we have for gasoline-fueled cars, we have a new architecture we've been using for a few years called TNGA, and it stands for Toyota New Global Architecture. And it is basically the architecture that's underneath many of our cars that we make now. And for BEVs, we've developed this new one, which is called eTNGA for electric vehicles. And the idea there is that it's not completely a redesign, and it's a mixture between some things that are fixed and some things that are variable.
What's really happening here is Toyota has made the decision that because they're really good at manufacturing their vehicles at relatively low cost, if they went ahead and made a complete battery electric vehicle platform, the cost of manufacturing that vehicle would end up being higher because they wouldn't be manufacturing at volume, and they would lose out on some of the advantage they have and what they've learned on manufacturing vehicles. The problem is that you're missing out on the efficiencies of making a full battery electric vehicle. This is something that Tesla has figured out. We can see it in the Model S refresh. We can see it in the Model Y, especially the Model Y coming out of Giga Texas and Giga Berlin. When we go to 4680, structural pack, front and rear castings, radically different way of manufacturing vehicles, and it's going to make it a lot lighter and a lot more efficient and a lot lower cost to build. And Toyota's Kaizen approach of incremental improvements is missing the potential of what radical change can do, because it's just not how they're wired. They don't think that way. They're bureaucratic. They have their way of doing things. This just doesn't fit with how they do things, and it's just a fundamental problem.
And so we think that with eTNGA, we actually can get the best of both worlds. We can not lose the know-how that we've accumulated, for quality and durability and reliability with many of our cars in the past, and actually what we are known for, while at the same time changing the architecture just enough so that it is accommodating to what BEVs are actually like. So, for instance, the batteries inside of eTNGA are within the floor pan, which is a very, very good thing to do.
Accommodating, right? It's not engineered for battery electric. It's accommodating for a battery electric system. You're just not going to achieve the level of performance, the advantages that you could get if you went all in on battery electric. So what we've got, if you think about this, what we've got is Toyota is hoping in 3 years to start testing their solid state batteries, and 4 to 5 years, 6 years, start manufacturing at scale hybrid vehicles that won't really be optimized for battery electric. And how is this supposed to compete with Tesla? This is the one that, like the Tesla Q community, when they say, "Oh, the competition's coming. Here comes Toyota. Watch out." Okay, so 5 years from now, maybe they'll start making a small amount of hybrid vehicles that won't really be competitive with the vehicles Tesla's making at that point. This is not good. This is just not good at all. More about manufacturing next.
TNGA and eTNGA can be flexed down the same assembly lines. Is that how Toyota is going to do that? Because others have said if you dedicate an assembly plant to making only battery electric vehicles because they have fewer parts, you can pick up a 25 to 30% labor productivity advantage. Which way do you think Toyota is going to do it?
So again, we are being very flexible in it. So we understand the advantage that you get by specializing the line just for one type of product, but we also think that it's very hard to predict exactly how large of a facility you're going to need.
Now, notice Tesla, he's basically saying they don't think they can sell vehicles at the same scale that Tesla's selling. Like Tesla is selling the Model Y at a very, very large scale. Tesla's going to be selling more Model Ys in a couple of years per year than Toyota sells Corollas. That's what's coming. And he doesn't see that they could make a battery electric vehicle that could sell in that kind of volume. It's not that a battery electric vehicle can't sell in that volume. It's that Toyota can't make a vehicle, a battery electric vehicle or a hybrid vehicle that would sell in that kind of volume. So they need to make smaller factories to make smaller runs of vehicles, which is inherently less efficient than making larger factories with larger runs of vehicles. You're missing out on economies of scale.
The investments in these plants, are very large, and they take a number of years between the time you make the decision to start one and when it's actually putting cars out.
And again here, remember, Tesla started Giga Shanghai and when they started building Giga Shanghai, the factory in Shanghai, they started delivering vehicles in about 11 months from dirt to producing vehicles in about 11 months. Toyota moves slow. Old auto moves slow. Tesla moves fast. Old auto doesn't go for large scale. Tesla's going for a large scale. Toyota's just missing the boat.
And so it's kind of one of those decisions where your predictive powers have to be very, very good.
And the other thing I wanted to mention is that Tesla is building their factories for significantly less investment. They figured out how to be efficient in the capital investment of building the factories, and that allows them to build the factories at lower cost, which increases margin because your CapEx, you're spreading the cost of that factory out over the number of vehicles. You make a large number of vehicles, and you were reasonable on your cost of making that factory, it ends up being a much lower cost in that vehicle you're delivering to customers. And Toyota just doesn't get it. The other car companies just don't get it.
And we believe that the optimal strategy for any of us is to be flexible when we're not sure, and then to become more certain when we're trying to squeeze the most efficiency out of it. So we will begin by actually having an architecture where we can mix different types of cars within the same line. And the reason that we do that is actually a very fundamental Toyota principle. You've probably heard about this Japanese word called muda.
So I think he's going to get into this more, but a key point here is that they want to be able to make different types of vehicles on the same line, where Tesla's just pumping out Model Ys on one line and Model 3s on another line. Toyota wants to be able to make RAV4s and Camrys and Corollas, maybe, Highlanders. They want to be able to make multiple vehicles on the same line. And he's going to explain this next.
And it means waste, and we try to get rid of waste as much as we can.
No muda.
No muda, no muda. I hear that all the time, and I tell people that all of the time. It's a way of life. Be as efficient as you can. But the other is something called mura, and what that means is try to have things as even as possible. Don't have sort of a sudden rush of cars that need to get made, and then the line is slack, and then it's a sudden rush, and then slack once more. And the way to have mura minimized as much as possible is to mix different vehicles on the same assembly line. And then what you find is, by the law of averages, it's very unlikely that sales will go down on both types at the same time, or even if there's three different types. And by mixing them up like that, you actually gain significant efficiency with making the volume, the number of cars built per day, much more even than it would be if you just had one line for each type of car.
So I think he's wrong about this. And what I think in particular he's wrong about is, number one, typically the first quarter of the year sees less demand. So a lot of companies may slow production in general for Q1 because there's less demand in Q1, some seasonal issue there. The concept that makes some sense is if we're making Camrys and Highlanders on the same line, Camrys a sedan and Highlanders an SUV, if we're making them on the same line and demand for sedans drops, then we can just make more Highlanders on the same line. And there's some sense to that. But what we're seeing with Tesla anyway is just pump out as many Model 3s and Model Ys as you can, and you just sell every one you make. And maybe they're going to get to a point somewhere where they hit some kind of limit on this, but we're not seeing it. When you're making vehicles that are radically better than the competition, you can sell in incredibly large volumes. And Tesla's ability, because they're making so much margin, because the cost of manufacturing a Model Y is so much less than what they're selling them for, Tesla has pretty strong pricing power to be able to say, okay, it looks like the demand for our vehicles at 60,000 isn't that great anymore. Let's drop the price to 55,000. Let's drop the price to 50,000. Right now, they're raising prices because they just basically have unlimited demand. But if there comes a time when they're making so many vehicles that there isn't enough demand for it, they can just lower prices. And the more they scale production, the more their costs go down as they get more and more efficient at manufacturing at large scale. So I think Toyota's missing the boat on this in a bunch of different ways. Next, we're going to get into autonomy, self-driving cars. We've got 2 clips on that.
Where's Toyota stand with its AV program?
What is important to understand about automated vehicles is that there's actually 2 different purposes for having autonomy within cars. One of them was for safety, to have active safety inside of the car. And I know that you recently did a program on so-called advanced driver assistance systems, right? And ADAS systems. And the ones that we have now are very effective at certain things. For instance, automatic emergency braking is very good at stopping you some of the time from having a crash in the front when you don't press on the brake pedal within time. We believe that automated vehicle technology can be used to significantly improve those systems and go even further in preventing you from having a crash. And one of the pieces of work that we've done quite recently is to expand the envelope that what we call a guardian type of system, which is there as an active safety system to stop you from having a crash, can actually work with the car in order to make sure that it doesn't hit something.
He's talking about just emergency avoidance maneuvers, slamming on the brakes or swerving to avoid a collision maybe. And this is completely different from what Tesla's doing in terms of FSD. And everything I've seen, they're not going anywhere near the level of perception and modeling of the world that Tesla's doing. But let me let him go on a little bit more.
And most of us are incredibly afraid to have a car skid. But if you're an expert driver and you're trained really, really well, you can actually drift a car. And I'm sure that you've seen lots of folks that have done it. I don't know if you've done it on your own, but it expands the envelope of what's possible in the controllability of the car significantly. And it makes it possible for the car to evade some obstacle. It could be a pedestrian, cyclist, anything like that, or some other car, by really using much more of what's possible for the car to do. And some of the advances that we've made in, again, this active safety place is to get the car to be able to be autonomously controlled, to actually drift around something to not hit it. And that's very, very neat.
It's kind of cool that Toyota is working on having its ADAS systems use drift ability to be able to navigate it. It sounds like a very narrow use case. This isn't going to come up a lot where you're going to need to drift to avoid a collision. But it's at least kind of cool that they're talking about it. And I imagine, Elon has talked with Lex Friedman in particular about how ultimately Tesla's full self-driving cars will be able to make maneuvers that ordinary humans can't make, or will be just better than human in a lot of ways and be able to do maneuvers that we might not have even thought of. So I think what he's talking about is probably not that big of a deal, but it certainly sounds cool and it made for a great video clip. Now he's going to talk about self-driving cars itself, and we're getting close to the end here.
The other area is what some people call self-driving. And this is where the person who ordinarily would drive the car can sort of take their hands off and say, I want the car to drive for me. Now, the technology inside of both of those systems, the active safety system and the self-driving, are remarkably similar.
No, they aren't. The technology inside Tesla's FSD is not similar to whatever Toyota is using for ADAS. But let's keep going.
They both have perception, they both have prediction, and they also have planning to figure out where they should go. But the most important thing to understand is that there's all these other difficulties with the self-driving end of things. And this has to do with, when will people accept automated cars? How safe is safe enough? Because with an active safety system, its job is to save you when you make a mistake. With the self-driving system, it has to essentially be the best possible driver that there is, and you never want it to crash, right?
This is putting unreasonable expectations on self-driving cars. My view, and I think if you follow my channel, you know this, my view is that if a car is better than even below average drivers, but particularly once it's better than the average driver, then if it replaces below average drivers, If it replaces drivers that are less skilled than it, then it saves lives. Human drivers crash. Suggesting that the only way we can allow self-driving cars is that they never crash is an unfair standard, and it leads to more people dying. Because if you stop allowing, if you have very, very safe self-driving cars, but they're not perfectly safe, and you say, well, they're not perfectly safe yet, so we can't let them drive. So instead, you have humans driving who are far less safe, but that's a dangerous approach. And it's not surprising that Toyota and the established industry would rather have more people die than allow robotaxis to come in and destroy the car market that they thrive on. Very negative attitude.
And so it's very, very hard, and the bar is much, much higher for that to occur. So to answer your question, I think it's going to happen in the short term for low-speed shuttle. And that's where the speeds are so low, the vehicle can always come to a safe stop. And I think the next step is going to be high-speed trucking. And then finally, after those are done, I think we will get to the robotic taxis that is really the dream that we've had ever since we started the whole thing.
I'm not sure who started the whole thing, but it sounds like Toyota does not see robotaxis happening for 10 years or more. And I see Tesla robotaxis happening in next year, a couple years, maybe 3 years. So Toyota is just way behind on everything. This is not a good look for Toyota, if you ask me. So most likely we can rule out Toyota as a threat to Tesla's future dominance of the auto industry and the robotaxi industry. It's just plain on its face that they aren't even close to innovating in the way they need to innovate. They don't have the right goals. They don't have the right plans. Their timelines are off. They're just dead in the water. There is one possibility, though, that Toyota is sandbagging, that they have something coming that we don't see. And I think that's probably the thing Tesla Q would like you to believe, that Toyota has some secret plan to come out with battery electric vehicles that are way better than Tesla's. Well, they're hiding it really well. And Tesla's being really open about what they're doing. They're not hiding anything. And you can start, I don't want to say they're not hiding anything. They don't seem to be hiding much. And we've got Giga Berlin and Giga Texas starting to produce vehicles. And we're going to see a radical change in the next year or two in the volume of vehicles coming out of Tesla, going from just under 1 million vehicles in 2021 to maybe 5 million vehicles in 2023 or 2024, and radically changing the car market. And then when they hit robotaxi, I think it's sooner. A lot of people think it's later, but 2-3 years maybe, we're going to see robotaxis in a lot of places, and that's a big game changer. I'm sorry, but Toyota, you're not coming for Tesla. You're done. Game's over. You might as well quit now. Keep making your money, pumping out vehicles that destroy the environment, pollute our air, and make people sick. Do what you got to do, but your time is limited. You're going to be done soon. If you like this video, please check out my other videos. Please support this channel on the Locals platform. You can follow me there. I typically do my Sunday live streams there, and I do exclusive content on there for people who are paid supporters. Check out the t-shirts like the Be Less Wrong t-shirt at elonbits.com or right here. And thank you so much for watching.